Hello and welcome to the FMCC webinar, Improving Energy Efficiency in the City of D.C., a Smart City Case Study, presented by Steve Nguyen. Next slide, please. I do want to let everyone know they have been muted for audio quality. If you do have any questions during this webinar, please feel free and type them into the question box at any time during the presentation, and we'll cover them at the end during the Q&A portion of the webinar. Also, if you'd like a PDF copy of the PowerPoint, one is available for you to download on your control panel under Handouts. Simply go to, it's usually the second to the last box, expand it, and you may download it. Also, a recorded copy will be on the FMCC website at fmcc.ifma.org. Next slide, please. The FMCC does like to let everybody know about their mission statement and vision statement, and this is our purpose. Next slide. The FMCC provides many services to the FM community, such as Ask the Expert, Find a Consultant, Locate a Speaker, and online educational resources. You may find more information at their website, fmcc.ifma.org. Next slide. And the reason we're all here together today is for the celebration of World FM Day. And actually today is the official World FM Day. Real quick. Well, I just want to thank our sponsors. And next slide, please. And World FM Day, today is the official World FM Day, but we're excited for World FM Day. So we've kind of stretched it into World FM Week. Next slide, please. With our 30 sessions that the FMC has created this virtual conference. And it's going still, if you've not joined us for previous webinars, we still have webinars going on today and also tomorrow as well. So we would love for you to join us. Next slide, please. And here's just a snapshot of some of the people that have and will be presenting for us. Next slide. And really what you're here for today is for Steven. Steve leads product and marketing at Building IQ to bring a suite of cloud-based energy intelligence service to the commercial, healthcare, education, and other building markets. Steve joined Building IQ from a consumer energy engagement company where helped utilities to better engage end users with their energy use through the power of disaggregation. For a number of years, he ran a corporate marketing and embedded solutions product marketing at the Internet of Things pioneer echelon, helping shape the market for today's smart buildings and early markets for smart homes and the smart grid. Without further ado, Stephen, I'm going to turn it over to you. The floor is yours.
Thank you, Joshua. So we have some learning objectives for today, and I want to thank everybody for coming. I want to thank everyone for coming first. We have some learning objectives for today's session. We want to understand a little bit about predictive analytics and kind of how they can uncover opportunity for energy savings. We want to get a basic understanding of whether or not your building or your buildings are IoT ready and what that really means in the context of a cloud-based solution or IoT building, if you will. And we want to look at some of the results and the context for some work that we've done with the City of D.C. And finally, learned a little bit more about how cloud-based software can reduce upfront capital costs. And that goes towards the way we think of internet-enabled buildings and the IoT of buildings. So the context for this is that in many senses, IoT is very poorly defined, and that's with good reason because it can kind of touch everything, if you will. In my past experience, we did embedded control networks and then internet-enabled all of the points in those networks so that you could literally have a 16,000 node building or group of buildings that covers all of the subsystems within a building, and with the inclusion of an IP router, make every one of those 16,000 devices internet aware or an internet host. But what was missing back in the day was the notion of kind of cloud control, because there really wasn't an infrastructure for cloud control back then. And what's interesting about today is when we look at the IoT, we really think of a cloud and we think of a device. Or in the case of a building, we think of a cloud and a building. And in many senses, we think that that's somewhat of today it's a little bit disingenuous in terms of the way the market actually works and the way buildings are actually run. And it also, I think, undersells kind of the value of what's already in a building. So keep in mind that in the building stock today, most of the Class A office spaces and much of the Class B office space has some form of BMS system. Whether that's sophisticated or unsophisticated is relevant in terms of what you can do with them, but it's irrelevant in the sense that they already have these sensing and control technologies inside of them. Even small buildings do as well, but they're very rudimentary. And so when we look at the landscape for building IoT, we really think of it in terms of 5 pillars, at least from our perspective. And one of them is the data gathering and analysis. There's a ton of data that's captured inside of buildings, everything from the multiple data points within a VAV to motion sensors, gas sensors, light sensors, to panel controls. All those kinds of things are sitting in a building, and gathering them is a non-trivial task only because it's difficult to get data out of some systems because the IT department gets involved, or the systems are on some kind of dedicated wire and a dedicated protocol that is not friendly with the internet, and so you have to build some infrastructure and all that. But by and large, if your building is 15-ish years old, it's probably got some kind of BACnet IP system in it, or it can be easily configured with a BACnet IP system through companies like Tritium. And that facilitates the ability to capture data. And of course, that data has to go somewhere, and typically where that's going to go is the cloud, just because there's a lot of data now, especially if you're talking about a large portfolio of buildings, or you want to do best practices and so on and so forth. So data capture analysis is a key component of the building IoT. The second part of that is what you can do in the cloud that you can't do in a building. And what that boils down to is processing. And when we're talking about processing in the context of predictive analytics and predictive control, we're really talking about models. So you could go in and do a physical audit and understand kind of the building, and that is a direct model, kind of an ASHRAE style energy audit 1, 2, and 3, where you're looking at the stuff. There's another way to do it, of course, which is really built around mathematical models. And so in many senses, what we end up doing when you're talking about an IoT infrastructure or a digital twin, if you will, of a building, you want to create a model using mathematics to understand what the building does. In the context of energy management and HVAC systems, you're really thinking of a building as a big old kind of heat sink. So how quickly does it gain heat? How quickly does it lose heat? Where does it lose heat quicker than other places, and where does it retain heat differently based on time of day and so forth? So one model that's created is called a thermal model of the building, and that model has to do with the temperature, the historical temperature, the historical energy consumption, the historical BMS performance, occupancy schedules, and occupancy patterns. All of those feed into kind of a baseline model, if you will, or base model of the building. And there are other models in play, but that model and the ability for that model to learn and grow, and even the creation of that model, is why we have the cloud. Because there's a tremendous amount of mathematics that goes along with building that model. We're constantly looking at data to update the model, so the model is learning. We use machine learning, which is a form of artificial intelligence, to make that model constantly relevant to the current building. So again, it's a historical model, but it has to be constantly updated to be pertinent to how the building operates on a day-to-day basis. The next thing or pillar of building a better IoT is, if you're going to initiate energy conservation measures, or you're going to do control, you need to measure and you need to verify. So the ability to measure and verify needs to be built into the system. And that also goes towards the model, because if you change something, you want to measure its impact. And then if it doesn't do what you think it should do, that should be brought back into the model. So the model then, the next time it spits out information, is based on relevant real-world results. Right? And verification, of course, is important because you want to verify what you've done. So if you make the effort and you go to the business exercise of justifying an expense, you want to make sure that you can verify the impact of that expense. The next element is quite a bit more advanced, which is control. In many IoT applications, we're really talking about sensing and then visualization, and that is given back to the building owner. So that is an IoT style. But in many senses, you would say, well, what is the point of sensing if you can't do control? So if you're sensing, you're analyzing, you're figuring out what's going on, you know what's broken, you know how to fix it, or you know how to change things so that, let's say, people don't get uncomfortable. That's control. You want to be able to do control. And in an ideal world, you want to do control in real time, meaning you know something's coming up, you can predict that it's going to change, and you want to change that the behavior of the building before the event occurs, so that the building doesn't spend a lot of money. So you don't spend a lot of money on energy. That's control, and that's predictive control more specifically. And of course, if you're going to do control, you want to measure and verify, you want to change your model, you want to capture data, analyze the data, and so on and so forth. So that's 4 pieces. The 5th piece is actually human capital. So how does that play? Now that goes towards how buildings are really run, and that's the facility management role, right? So the facility management team in general and individuals have a tremendous amount of expertise about what really makes a building work. And they are the client human, the human interface with the tenants, right? And so the whole goal here is not to displace the facility role, but to actually use technology so that it makes sense to enable the facility role. So it's really a question of how can this technology help you rather than how can this technology remove some burden from you, remove some tasks from you. Now, removing those tasks could be a very good thing because it allows you to focus on tenant-facing issues or issues that really drive kind of the business. And it also means that all of the kind of grunt work that's accomplished with this cloud-based analytics is done for you. So that's a good thing. The next part of the good thing is that we and others, companies like us and our competitors, we offer services where you can go in and we offer kind of oversight. So we do that first level of data analytics. So it's one thing to get hundreds and hundreds of alerts a day. It's another thing to get an email every once in a while that says, this one thing needs to be fixed. Here's the whole laundry list of things that are going on, but this one thing is really important that you need to focus on. And that requires, more often than not, a combination of intelligent software and intelligent humans. So one of the things we like to leverage through a network operations center is building experts that are also looking at data and understand how to use and understand the data, perform a building-focused diagnostic around that data, and then work with the facility team. So again, augmenting the capabilities of the facility team through technology. So those are the 5 pieces: data capture, analysis, modeling, measure and verify, control, and human capital. So from our perspective, it really comes out like this. We've got a bunch of external data sources like weather, tariffs, gas, water, steam, other types of things. They're fed into our system. On site, we're pulling data out of the BMS. So we get that physical model, we get the control potential of the building itself, we get smart meter data, put it up in the cloud, do our analytics, do our modeling, optimization, trending, etc. All that's done in the cloud. We have a bunch of services, and at the end of the day, the facility team and the building owner get a solution. And that solution is really comprised of a bunch of core services. So solutions may range from managing peak to doing energy efficiency to doing some sort of fault detection or even demand response. So that's the way Building IQ works. And effectively what happens is these are the core services that we supply. All of these are used by our clients in the kind of which ones make sense for me and how do I meld these together to build a solution that's right for me as a client. So the advantage of providing a platform to the facility industry is that the facility industry as practitioners can turn around and say, I don't need these pieces, but I need these others. And I want to combine them. And so in almost every instance of working with clients, there's some form of tailoring that's done, and it's not a cost load to the facility team. It's merely a question of what is the right solution for you. And so we offer services from visualization through something called Energy Worksite, through a data-driven retro commissioning project, through complete HVAC systems, through something we call outcome-based fault detection, all the way out to something we call predictive energy optimization, which is an ability to actually predict how a building will react based on upcoming weather, based on upcoming pricing, and drive down the energy costs. That is done 24/7. And at any given moment, once we are beginning to pull data from the BMS, our human capital comes into play. So we are immediately beginning to provide sort of a third leg of your own organization, or a cloud-based leg of your own organization, where our energy folks, our building folks are looking at the data for you and then informing you as to what they think is going on in the building. And then in a collaborative way, we help you or you define what is really going on inside the building. Because we're looking at data, but we're not you. We're not sitting on site and really understand the ins and outs of the physical parts of the building. We're really kind of data experts, combining our data expertise with generalized building expertise and say, hey, this is what we think is going on. And that's provided all across the board with the exception of just a pure energy visualization service, which is also an option. And then underlying all of that, of course, is the ability to do ticketing and escalations and measurement and verification. Right? So at any time you run some sort of change in your system, we can do validation and measurement for you. Again, all of these are services that are available to you, but it's you, the client, or the facility team that kind of defines what a solution looks like. And so we take customers on a journey from what's going on to improving performance to improving marketability. So many buildings in the North American market especially start with visualization and trending and benchmarking. And you begin to understand what's going on with your energy. But there's a next step, of course, and that's taking a deeper look at what's going on with the energy and really beginning to treat energy data as an information source. And then what can you do with that data in terms of identifying faults or validating a work or doing a commissioning project or retro commissioning project. So what we end up doing is we take the data, we transform it for you, and help you improve performance of the existing building. So no capital cost really, except for the lightweight appliance to pull data out. But at the end of the day, you get improved performance because we're combining data, building expertise with your own building expertise as a facility team. And finally, on the last part of the journey, if you will, we move into the point where the building is able to respond to the cloud. So we can do control at this point. We control very few points because what we try to do is look at it from a holistic perspective. What are the few points we need to control to have a desirable outcome? And that desirable outcome is typically decreased energy use, somewhere in the order of 10 to 30% on the HVAC side, an ability to do intelligent DR, and an ability to always run in optimized mode without any impact on the tenant. So comfort's always maintained, efficiency is always optimized, and at any given moment we can transition into DR. That requires a fairly sophisticated building, requires good transparency and cooperation between our team and the facility team, but it does mean that the building runs as efficiently as possible from an energy perspective. And because the data is being exchanged in this cooperation, there's always this element of 24/7 cloud-based assistance for the facility team to identify anomalies and then diagnose those anomalies and continue to tune the system on site. So modeling is the core, and you really need to think of it as it's not so much what we do, it's what you retain, what you build as a result of attaching a cloud-based analytics service to your system and your facility. The knowledge is basically captured in the thermal model of the building, how the building acts historically and how then predictably it will react in the future when weather changes, occupancy changes, and so on. The other model is what we call a control potential model. Again, this is a deep data-based understanding of how the BMS responds. So if you want to push temperature, half a degree in one zone up and half a degree in another zone up and they're adjacent, what does that really mean in this system? And it's captured in data so you understand what so you can always kind of predict what that system is doing. At the end of the day, you get a deep database understanding of the system to go along with your expert level understanding of how that building reacts as a facility team. So you've got the human expertise combined with the data expertise, and that is a control potential model. So you'll always know how the system will react under any kind of given circumstance, particularly weather, occupancy, equipment changes. It's all beginning to be modeled for you, right? And so that's another key model. And the third model I'd like to discuss before we get into the DC stuff is the whole idea of a comfort model, where the tenants are providing feedback, but that feedback is not to enable control, but to enable an understanding of how they are interacting with the space. And so it's that kind of combination of three things: how the systems work, the building physics, and the occupant's intelligence. That kind of intersection is at the end of the day what is built with the facility team in mind and with the building owners in mind. And that is the net of the services we provide, is that high level of intelligence and understanding about the facility and the occupants and the systems, which enables buildings to be better run and empowers the facility team. So that's an introduction of Building IQ, and now what I'd like to do is talk a bit more about the City of D.C. So we were working with the Department of General Services, and what they were really trying to do is not so much a straight-up evaluation of a technology, but an understanding of a set of processes and a set of technologies that can work on their buildings. So the scope of work was really around HVAC system optimization across 8 buildings and about 3 million square feet of controllable space. And these are standard office spaces as well as hospitals and high schools. So it's a good mix from a portfolio perspective if you're a management company or you're a holder of mixed-use space. It also gives the City of D.C. a good kind of sampling of what they have in the city: office, hospital, and school. So they had some performance expectations really around this whole notion of predictive energy optimization, including in there is how does it work with an OK system versus a state-of-the-art system. Is it a sustainable savings? Because most of the problem with energy services is that they begin to decay in value over time. The other expectation was they want to be able to apply kind of one technology platform across all building infrastructures, which is, as you would guess, is a very difficult thing to do. And it works because we're looking at data first and foremost, and then not really deep control, but controlling just the right pieces of the BMS. And so it's very important to the City of D.C. that they not have to do any RIP replacement work. Now, they fully expected to do upgrade work and fix-it work, but they had no intention of saying, oh, we want to use this piece of software, therefore we're going to we're going to pull out a bunch of systems and replace them. That was not part of the criteria. It definitely would have been a non-starter. So it's really about utilizing the existing BMS, the existing infrastructure, minimal cost. Again, I talked earlier about a simple appliance that pulls data out of the BMS, and then being able to understand the metering and use the existing infrastructure. Right. Bonus points, of course, were awarded because there's the notion of measurement and verification. So again, the system that we supply to the City of D.C. has built-in measurement and verification. We actually do something called automated M&V. And in parallel with that, we are working with the city and with Lawrence Berkeley National Lab so they could validate the project results as well as the performance of M&V itself. So that's the context, and working with an implementer called New City Energy. So that's the framework for the project. A little bit about DGS. You can find them at buildsmartdc.com. It's roughly 100 buildings, and they're looking to implement kind of an industry-leading energy monitoring across their portfolio. And so it's really important for DGS to understand energy consumption within individual buildings and then be able to, again, apply technology to those buildings to improve energy consumption and energy efficiency. So specific goals of the technology are to limit consumption, so limit resource consumption, reduce the environmental impacts, lower the costs, which has a lot to do with not allowed to rip and replace. That's not a viable solution. Extend the life of existing assets. So again, take your existing BMS and make it work better, and then therefore make it more valuable over time, and expand that time frame if possible. Improve operations, because there's a general understanding that operations can be improved. That has a lot to do with how the systems are either implemented or run, and how they decay in performance over time. And then finally, take steps towards engaging the occupant, which is work underway. And engagement can include things like mobile, which we did not supply as part of this project, but we did supply educational events and run in-person seminars with the clients, the tenants themselves, to understand the difference, for instance, between controlling the air handling units versus controlling deep down into the zones, for instance. So the scope was working with BIQ, us, and the Department of Energy. Worked also DOE and Lawrence Berkeley National Lab. Implement the protocols, kind of get a litmus test and understanding of how we're going to do M&V, measure that M&V. That's Lawrence Berkeley National Lab's role, and then deploy one platform across a representative set of buildings. So it was very important to have very different, disparate types of buildings in the program. Again, from schools to hospitals to commercial spaces, and then even within those things, those types of buildings, vary the type of BMS stock, BMS technology that was available, to prove out the notion that one kind of energy management platform can service these kind of a highly diverse range of 8 buildings that they chose for this particular project. So I think we covered this. Implementation standards and protocols had to be effective at scale. Again, the whole notion of a cloud-based solution was very important, rather than an embedded software solution, for instance. And then, of course, the ability to implement those technologies across a large portfolio. So let's talk about learning and results. And I want to remind people you can ask questions at any time. So first, learning. When it came to the selection process, the focus was on airside systems, and looking for systems that had air handlers and VAVs. So that was the first thing, was to establish some reasonable baseline criteria. Now, the goal was, of course, not to eliminate things as so much as to make sure that there was just some basic capabilities within the stock that we were testing and implementing in. From a controls perspective, since they had so many different types of control systems, it was determined that BACnet systems would be the target, and BACnet IP-based systems or enabled systems is what we typically work with. Although we can work with other things, that's probably the smoothest path forward. If you have a system and you can it's either already BACnet native, or it has a BACnet IP layer, and or can be updated with Tritium to allow translation into BACnet. All of those things work. The other thing is the network is important. The building system has to be on the network. In the absence of a network, things become very, very difficult where a network needs to be put in place. So something that has no network would be almost a non-starter. But given that, it was important to have the flexibility to mix and match kind of physical layers within the building, right? So they wanted to make sure that they could use wired or Wi-Fi or cellular. So those were part of the implementation. That was less about actually implementing it than it was about proving that we could do it, right? And lastly, want to be able to make sure that we could pull in meter data. So clearly that meant if it's a smart meter, we can get the meter data from a utility. If it was not a smart meter, we could get it through either a pulse counter, pulse input, or we could get it off of the CT clamp. So that was fairly straightforward. It's just a question of standardizing on the meters that were put in place. Given that DGS has a Green Button Connect API, we were able to work with that. And also we were able to submeter, again, using either a CT clamp or a pulse input. So all of that went into the building selection. Insofar as the team, there's really, from their perspective and from ours, it boiled down to coordination and communication. From the perspective of working with 8 different types of buildings, with 8 different types of systems, and kind of 8 states of performance, if you will, executive backing became critically important. And we had four major players in place. We had DGS, we had the implementer, we had the client, the BMS provider, right? So it was very important to kind of logistically coordinate all that communications. And the next thing was to get ahead on the facility and engineering management side. So I think one of the big issues with energy optimization companies like ourselves is that there's a great amount of distrust within the facility management team about some cloud-based control company coming in. And so it was very important to dispel the notion that we were trying to displace the facility team, which again, as I described up front, is not at all what we try to do. Nevertheless, it is something to think about, and something that we had to address in each of the 8 buildings to make sure that by working with a facility team, that it was clearly understood to that team that we were here to help augment their capabilities and help identify things that through data that would be very difficult to identify given the day-to-day responsibilities of the team. So that was an education process that had to come together, and it was also a built-in process in the way we go to market, and should be clearly understood by folks listening to this webinar that the technology is here to augment your capabilities and not replace your capabilities. And so that is something that needed to be done up front before anything was put in place. The last comment I want to make is since there were tenants tend to get very vocal when they get uncomfortable, there's a fair amount of tenant education that went on up front as well, and also went on through recurring sessions as we made modifications to the system that were fairly substantive. Again, like moving from air handler-based control to zone-based control. So this is the basic process that was implemented at DGS, with the DC through DGS. we were putting in a device that allowed us to pull in data from the BMS in addition to the metering data. That was pushed up into our cloud, and what we do is we track that each point in a dashboard/portal that we maintain in the cloud, and we provide access to DGS and the facility teams. But more often than not, we manage the cloud. So the ability for the facility team to do anything they want is available through that portal. But in this particular case, we were doing the work through the portal. So the data comes in, Building IQ identifies any anomalies, and we do that by basically looking at patterns. And some patterns are very clear, like a flat line, I'll show you that later, and some patterns are less clear. And so our data guys look at this on a manual basis, and then we have automated tools to identify certain types of things that happen in the data stream. So once that anomalies are detected or trends are detected that need to be watched and managed, we then go and start working with the facility team to help kind of negate or mitigate the impact of those anomalies. And so more often than not, they're kind of little things that don't really impact at the end of the month, the bill, but they are something the facility team needs to be aware of. In instances where they're something that really impacts the client, and this means it's going to cost them money, it's going to make the tenants uncomfortable, or it's something that's kind of intrinsic in the way the system is operated that could be improved, that is brought forward immediately, if not immediately, at least on the weekly, and then summarized in the monthly interactions. And so there's always this notion of someone kind of helping you out. And again, this is directly with the facility team. Working with the facility team, say, hey, have you seen this issue? We're seeing this in the data. What do you guys see? And that's kind of how that interaction works. Certainly, we can include the ticketing system in there, but that's in this particular case, we didn't implement our ticketing system. It was DC's ticketing system, but it's the same process. The ticketing is submitted and auto-signed. The contractors or workers are notified. Tickets are completed. The point of discussing it that way is that completion kicks off another look-see. So remember, we're looking at data, and we have the historical data. It's part of our verification and measurement process. This is kind of a, if you will, while it's certainly a data check, it's also kind of a manual gut check that says, hey, this stuff was done, and it looks like it had the right impact. It's annotated in the system, and it's there kept for the facility management team to access at any time, when they can go back in history directly and say, hey, this particular sensor, this particular unit had some issues. Let's go see what it was in the past, and you can see that, like a sensor on that particular piece of equipment was failed. It was replaced, and it came back into expected action. And so we can see that in the traces, and we also annotate it and store it for posterity in the portal. So the facility team has a nice historical record of what's been going on from the data analytics side. So let's take a look at this one particular building, euphemistically called Building 1. You can see, if you look at the upper left chart in the summary table below the chart, we were able to achieve approximately a 4.5% overall energy reduction. So that's the whole building reduction, which translates to, in this case, March, April, May, approximately 3-month savings of $5,500. What's interesting about this building, this particular building, is first of all, it was a new Johnson Medicine system, and it included some native backnet stuff. I'm not sure actually what it was in there. The reason it was included in the study was because DGS felt that they wanted kind of a benchmark, if you will, where they could say, okay, here's a building, it's already well run, it's already got its certifications. We just want to make sure that when these guys show zero savings, that we have this baseline to compare with for our other buildings. What was surprising about it was that we were able to achieve 4.5% whole building, which translates to about 8, give or take 8 or 9% on the HVAC side. And you can see in the monthly traces here, actual versus baseline, month over month for the 3-month period that this report shows. So these are the kinds of things that were achieved with this building. More specifically, I'll show you some of the data traces, but this is the net result of this 3-month period for Building 1. Building 2 was interesting because a different building, different construction entirely, therefore a whole new different set of models applied to this building. And remember, while the models are built in the cloud, the models are specific to an individual building, and they learn specific to that individual building. So looking at this time period now, we're talking September 15th through May 16th, a cum of 91,000 in savings on the energy spend. And so we're talking about 9% whole building, which translates again to about, give or take, 18 to 20% reduction on the HVAC side. Now this one they expected to see savings, so again the first one was meant to be their kind of zero savings benchmark, and this one they expected to see savings. It was a bit older building, a little bit older, less energy efficient construction. This is seeing that, and the cum was a little over 90K. And again, on the lower right, you can see month over month the baseline versus actuals. So actuals are driven off of the meter data, where we're doing whole meter, and we're using data analysis to figure out HVAC. If you look at the baseline is built historically. So we grab a year's worth of data on the spend, a year's worth of data on the energy use, a year's worth of data on the BMS performance, and we also get the weather, historical weather from weather.com, and we get the occupancy pattern, and then that helps us create our baseline. The one caveat I would say to you all here on this data is that the occupancy and usage model for each building did not change year over year. So it is a consistent usage of the baseline, which is a requirement, where the building usage from the baseline period to the actual period is the same. So occupancy doesn't change dramatically, BMS doesn't change dramatically, type of user, type of tenant, if you will, doesn't change dramatically. So in other words, you don't go from an accounting office to a hardware lab. This is a good example. So that was Building 2. So let's look at some specific anomalies. So there's this one is this is the kind of thing we do. We're looking in this particular case at AHU1 for a 2-month period, looks like. And so what we're able to do is isolate the different data that we track. We can track hundreds of points. In this particular case, we're looking at AHU1 and the power meter. And so you can see that there's a sudden failure or sudden power change. And our initial diagnosis is that there's a sudden failure where there's been an incorrect setting change. The point here is this is kind of a hidden change in a typical building system. So we isolate the kind of just the energy from this particular piece of equipment in this particular way, and then we can say our guys are looking at it, well, this doesn't look right. Historically, it's been at looks like 800 and 600 range, and now it's all of a sudden it's dropped. So that creates an anomaly for us. And this one I think was picked up. I think all the ones I'm showing you are going to be picked up manually. So again, our guys are looking at this, and they're augmenting the facility team, saying, hey, there's a problem here. We need to go check it out. Here's another one. This is the one we decided was a schedule anomaly. This is what we would call an operating error. And basically what was happening is the set point was set, but the heating and cooling were fighting against each other to maintain that set point. So kind of a doubling up of I think there's the one that was kind of a doubling up of the air handler load. So again, looking at the data, looking at the energy, and knowing best practices, we are saying, hey, there's something wrong with this thing. We believe it's this. And then we go back to the team and say, this is our analysis. These are all the data. Let's go take a look at it. And almost in most cases, the facility team is doing that all on its own. They just needed the data to help them understand that there's a problem. So again, difficult to do when you're on your own looking at data traces. Much simpler process when there's another team sitting in the cloud doing that first level analysis for you and saying there's something you need to interrupt your data, go fix and take a look at and analyze. And if it's nothing, it's nothing, but the expert on the ground is the facility team. This is another example, chiller operation issue. We're operating simultaneously to avoid a temperature loss. So that has to do with the way the chillers are being run. And this is not always something that we can track and trace. We're not often, or not always, I should say, given access to this data. In this case, we are. And so we're able to identify an anomaly in the operations of the chillers. And this has been going on for some time. This particular period, let's see, is a couple months, right? So, well, actually, I'm sorry, 1 month. So the resolution was to modify the program and specifically bypass the valve scheduling. So this was, we think, was a simple human error, and it wasn't an error in the implementation. It was the error in the returning it to its previous state, which is a pretty common problem as buildings age, as you know, and as facility teams turn over and people get busy, schedules change, or schedules are changed on the operating side, and then they're not changed back. But that represents an anomaly for us, not a pure data anomaly, but a trend anomaly. And that's kind of thing we look for on a kind of daily, weekly basis where things change. That might be okay, but when they don't change back, that represents an issue. In the data science world, we kind of call that light data science. It's not truly analyzing data, but it's looking at trends and patterns. Again, something that's done by the network operations team. Here's a negative pressure values when the equipment is off, possible sensor calibration. So sensor calibration is a big issue. We've gone into sites that are supposedly working beautifully. And part of what we do is, again, recall I talked about a control potential model. The control potential model is fairly straightforward. It's kind of a learning feedback process or loop. If you're looking at loop tuning, kind of old school stuff. But basically, we push in data and we expect to see a change. If the change doesn't occur as expected, we go try to figure out what's wrong, because we're pushing in data and pushing in control kind of upstream, in this case the AHU level, and we expect to see a downstream change at the zone. But if that downstream change doesn't occur, then there's an issue somewhere in that long chain of things that constitute the building control system. So in this case, we discovered this calibration issue. And a calibration issue means that the software and the people think that the system is doing something, but the system is playing by its different set of rules. And so this was just a calibration, a particular sensor that we discovered on a calibration, with a calibration problem. And we've actually been in sites where literally all of the room temperatures, room temperature sensors or zone temperature sensors were poorly calibrated. And so the system was constantly fighting to maintain any kind of predictable temperature. And of course that meant that you couldn't use cloud-based control, because what our algorithms were showing showing what should happen were not being validated by the system in any way, shape, or form, because the calibration of the system was off. The system would say one thing, the temperature sensor would return the wrong value, and then people would be either hot or cold because the calibration was all wrong. And I think I mentioned something about a down sensor. It's actually this thing is just locked. So again, sensor level data easily picked up if you're paying attention. Very, very difficult to pick up if you're not paying attention. I mean, you're talking about hundreds and hundreds of data points coming out of a system. It's pretty unreasonable to expect the facility team to sit there 24/7 looking at this stuff. Again, that's why we would do that as a service. While of course you can do it on your own, it's often advantageous to have someone else do it for you. All this is provided to the facility team. So facility team can see everything. They can do control from this panel. They can turn things on and off. They can change schedules, change set points. All can be done through the panel. But at the end of the day, it is a lot of data. And more often than not, our clients and clients that we've talked to, potential clients we've talked to, say we really just don't want to do this. It's not what our facilities teams are for. They're not designed to sit and stare at screens and understand data. So that's a service we provide. I'm not sure how many more of these I have. Oh, that was the last one. So damper operation, you can just see that there's a hunting issue. Again, an issue, a very specific issue with a particular piece of equipment. And if you imagine if all of these right-hand items were colored in, which is we turned it off so we can make this trace for you, you would see even something as seemingly obvious as this can get hidden in the noise of all the data. So, in summary, with DGS, because we're looking at that data not only at individual point level but at a pattern level across all the different buildings, we were able to identify numerous issues in the buildings that the on-site team was not aware of, and I kind of explained how that happens. Whole building savings of 95%, which translates into roughly double in the HVAC side, which is where we actually play. And we were able to prove applicability of one piece of software across multiple BMS types. And of course, the net of that is you were able to leverage data analytics to identify mechanical issues, process issues, and operational issues. All valuable things to DGS. So from an additional benefits perspective, for buildings with variable refrigerant flow systems, we think there's a 6 to 12% kilowatt-hour reduction opportunity based on our analysis of working with the buildings. We think there's an additional 15 to 20% kW reduction as a DR potential. So that's an interesting proposition for DGS. And of course, we were able to show some areas for improved maintenance, basically being able to say, look, there's equipment that's trending weird. You want to do some preventative maintenance on it. And so also port of discovery, we were able to identify controls issues, physical issues like the calibration of sensors, for instance, is one. Faulty AHUs or others that we found. A whole bunch of stuff that was found basically because we're doing the control potential model, and we're constantly making, not constant, but we make little tweaks and changes to the system day to day. And if those changes don't realize, A, yes, we question what we've done, but B, if what we've done seems right, then we start looking at the HVAC system itself, and then are able to identify areas where the control system would indeed need to be upgraded. And finally, we've started to work on solar integration into our optimization engine in a couple of the different sites. So next steps, what we did as a result of this work is we basically ran a series of sheets on the 8 buildings. And the plan is to expand the scope of the project beyond those 8. Try to intentionally bring in a wider range of HVAC systems to stress the system more and more, and then be able to offer more as a service, some specific areas of our service offering on top of the platform. So currently looking at additional schools to bring in place. Some of the projects we've identified that the city is looking into, and that they would do this on their own. That yes, they could do it with us, but they also can put it out to bid, of course, would be specific HVAC retro commissioning projects, which we've helped identify. Looking at some kind of managed continuous commissioning effort. And finally, for some of the buildings moving from AHU level control to zone control, and getting even better results out of predictive energy optimization, which is, again, the whole idea of predictive control and analytics. And with that, I am done and happy to take questions.
Great. Excellent presentation. If anyone does have any questions, this is just a reminder, feel free to type them into the question box. I'll be happy to present them to Stephen. And also Stephen's email address is up on the screen right now. So if you do have any questions, you can email him. I'm sure he'd be happy to follow up with you. And if you wanted a PDF copy of this PowerPoint presentation, you can go ahead and download that now on your control panel and you have a PDF copy of that this presentation. While we're waiting for, see if any questions come through, can you go to the next slide, please? We just want to let you be aware of some of the upcoming webinars left in our virtual conference. The next one will be Simon Davis presenting space utilization, not just about the dollar savings, the impact of agile working. Next slide, please. The FMCC does have an app. If you haven't downloaded it yet, I encourage you to go ahead and do so. You can do that at Google Play or iTunes. Next slide, please. And FMCC is always looking for volunteers for their STAG team. If you have a webinar presentation, a white paper, etc., that you think would be befitting for the FMCC, we encourage you to contact Ricardo. His email is on the slide. Next slide. And the IFMA FMCC always does like to bring awareness to the other councils and communities that are out there. Next slide. And again, I want to thank Stephen. It was a fascinating webinar. I want to thank you for your time and your great presentation.
Thank you, everyone. And thank you, Joshua.
Have a great day.
Bye-bye.
Bye.